Hello, thank you for coming to the information session for the Engineering Tech Department. My contact information and Sean and Robert Hicks is shown, as I'm sure you've already been given that. We teach multiple CAD platforms, as you can see above in the list, and we work on an NC programming certificate. So a little bit about our program. We basically have a 2-year program that can transfer into a 4-year program with Central Washington. Also, Clover Park down in Tacoma has a program for us. So we have this 2-year degree that can go into a 4-year degree, and we can look into that further. You've probably already been explained that. What we do in technical design is pretty much anything you see, touch, or feel we do on CAD now. From making homes and buildings to mechanical parts. This is used in many different fields now. Some of you probably already aware that they've done it in aerospace and automobile industry and heavy equipment and stuff. But we even use CAD design for biotechnology for things like prosthetics and internal organs, artificial parts. So many things can be done with the CAD program. Basically what we do is create parts and then make drawings with it, creating dimensions and such. We can have a simple part be multiple things here. It can be one part or multiple parts smashed together. For example, like a weldment or something like that. So we take these detailed parts and make drawings. Back in the day, we had drawings done on ink and mylar, or even before that, vellum and pencil. But nowadays we're using a CAD station and we're creating parts and drawings all using the computer-aided design. You could be indoor, you could be combination indoor outdoor. You'll have a CAD station of some sort, and some cases we are actually working in the field. So I've had students leave this program, do the design, but then actually go out in the field and help the designers or help the manufacturers actually build the part. So we have multiple CAD range of what your income is. Basically, the higher level you are, the longer you've been in there, or more experience you have in the shop, the higher position you can get for a higher pay. I'll just tell you my story. I started in a program like this. I came out and started working for Boeing for about $7 an hour, and from 87 to 95 I went to $70 an hour. So in that time I used this degree to become an engineering tech designer for multiple companies such as Boeing and Airbus and Freightliner and other small companies you might not recognize. But it gave me an opportunity to do not just engineering tech design. I was also an NC programmer. I was a tool designer. I've been an instructor for multiple companies teaching CAD and engineering tech design. So it could lead to all kinds of different positions, and it starts kind of a low rate until you prove yourself, but once you prove yourself you get a much higher cap than a lot of positions. These are the kind of skills that you'll need. A lot of people get intimidated with the math and English, but we do have tutors here, especially with the math class. In all our engineering CAD classes, we have a tutor. We have a class actually specially designed to help you with your homework. So if you want that extra assistance, we do have a class. It's the skills building class. And you can take that and you'll get an instructor working with you one-on-one to help you complete your assignments. I would say the number one thing on this list is to be a team player. Managers are constantly asking me for referrals and stuff, and the most important thing to them is how well do they work with other people. So you want to have examples of how well you work with other people, not just tell them you can work with other people. In what way are you able to be a good communicator? I'll finish this off with some examples of former students. This student designed his entire wheel off his BMW. He actually was trying to build this hubcap because his broke, so he built one, and then we ran it on a 3D printer, and he put it on his car, painted it up. Couldn't tell the difference from the original one to the new one he put on there. This is a drone. Some of our students worked as a capstone project, and they built the drone. They also built the remote control. So there's a lot of components that go into making something like this, and this was their particular drone that they built. We reverse engineer parts like the ones you see in here, the CV axle, the lawnmower differential. We take it apart, we reverse engineer it, meaning we measure it, and then rebuild it, reconstruct it on the CAD software, try and find out what went wrong with it and see if we can't improve the design where it flawed. So those were some of the examples from my reverse engineering class. This is an example of the capstone project. This particular group decided to put greenhouses on top of all the skyscrapers in Seattle. Lots of access to sun, so we could make use of the facilities there. This was an actual project done for the Oso Fire Department. They had a big mudslide a few years ago, and they discussed being able to transport people through the mud much easier. What you have here is a part that is collapsible. You can see the hinges here where the parts will fold. You can slide it into a helicopter, unfold it, and then people can be transported in more than just one person, and can be moved from one spot to another much more quickly than just in a basket. This was a TIG welding chair that was designed by the group using things from the Amtech facilities such as machined parts, sheet metal parts, weldings. We have weldments on here. The seat is a composite seat, so we're trying to apply a lot of the things that you would learn here in the Amtech facility to the engineering design. This was a fun design. It was designed actually to recycle plastics. It can actually melt rubber tires, styrofoam, becomes a gas. That gas goes into a tank of water, which becomes a liquid form. The gas will float above the red water line here, and once the liquid gets over this tube, the oil gets over that tube, it goes down into a tray, and you'll have unrefined oil. So these were some examples here, other examples. This one here was designed as a shelter. What's really neat about this design is you can pull out one pin and the whole thing collapses for each compartment, and it's very quick to set up and put away. So you could have it in a shelter, homeless shelter, during the night so people could sleep, and then tear it back apart and then quickly get it out of the way for the next day. This is also, we have a surfacing design class. So our advanced surface class, this person built a actual size wing for a Cessna, and he actually did a video on it. If you want to go try and find that, it's in YouTube. But we learn about surfacing and about wings and how they work. So this student did a actual reverse engineer of a Cessna wing. We have fun too. We do some crazy parts. Even though it might not look practical, it's called the hamster wheel. You run and then it generates power to recharge batteries. But you can see there's a ton of components involved in this. There was a lot of work for that particular team to come up with that design in just 10 weeks. We called this the Ferris wheel. So inside your refrigerator, you might have a lot of rot in your crisper, if you're like me. This idea was designed so that you could get access to things better and things wouldn't get rotten down on you. So there's your CRISPR idea. We've done actual real work for Volunteers of America where they gutted out a building and we redesigned a floor plan for them. This here was a design created by contacting the city of Seattle. We asked Seattle what was the biggest problem they have, and the biggest problem they have was the honey bucket. People didn't like them, wanted something that blends in with the nature better, so our group came up with the royal flush and came up with their own outhouse idea. Just one last idea here. This was back in the days when we were going to school and we would have a lockdown. In the event of a lockdown, we could take our chalkboard that we're writing on, roll it over to the window and lock it in place. There's a locking mechanism, as you can see over here. We could have that locked to the wall or up into the door, and what the advantage would be was it's locked up so they can't bust through the door. They can't see anybody if you turn off the lights. They don't know who's in there. And it was a bulletproof board, so it would help resistance of bullets being shot through that area. So these are some of the ideas that some of our students have done, and hopefully you guys got to see some things that we might be doing. If you would like to discuss this further, you had my information in the beginning, and the person leading this meeting will help get you in contact with me. Hopefully you learned something, and hope to see you guys soon. Please feel free to set up a plan with me or set up the time to create a 2-year plan or just get more information about the program.